Hello and welcome to iStream Ophthalmology, learning ophthalmology made simple by Dr. K. Suresh. Today we are going to learn about simple transposition. Before going into our topic, let's try to understand what are the components of a normal prescription. So here we have three components. A normal prescription ideally has three components. The first one is the sphere. It can be a positive sign or a negative sign depending on whether the patient is a hypermetrope or a myope. So we know the sphere is uniform refractive power which is acting in all meridians. Okay. Then comes the cylinder. Again, it can be a positive or a negative cylinder. This is the additional power requirement, and that requirement is in only one meridian. So the third component is going to tell us at which meridian this cylinder has been prescribed. Okay, so we have a sphere, a cylinder, and the axis at which the cylinder has been prescribed. Okay, so let's see some example. Here we have a minus sphere. Most probably this is a myope, so he has been given a minus sphere correction. The minus cylinder which is required has been added and the meridian is 90 degrees. Okay, so this is a compound myopic astigmatism. So this is how the prescription of a compound myopic astigmatism looks like. Now let's look at another example. This is a compound hypermetropic case where the sphere is a plus sphere, the cylinder is a plus cylinder, and the axis is 180 degrees. So here everything is plus. Now suppose the patient has just simple myopia or a simple hypermetropia. Then what do we do? Then the prescription will not contain the cylindrical and the axis details. They will have only the spherical correction. If it is a hypermetrope, maybe in this case it is a +4 hypermetrope. If it is a myope, say -4, then the prescription will read as -4 diopter sphere. Okay, now suppose the patient doesn't have or doesn't need a spherical correction, then only the cylindrical correction that is required is mentioned, the power of the cylinder and the axis at which it is required. So this is how a spherocylindrical prescription looks like. Now we have seen how the prescription of any patient looks like. Now comes another important question. If the prescription is the same, will the physical shape of the lens also be same? To understand that, we have to understand that every lens has a front curve or the front curvature and the back curve also. Okay, so any lens, whatever power we are suggesting, is the total power of the lens is given by the addition of the front surface power and the back surface power, and this is known as the nominal lens formula. Nominal lens formula. Okay, so whenever we say the power is +3, for example, that means it is an addition of the front power and the back power. Okay, so that is the total power of the lens. Now comes the important question. If the optical power is the same or constant, must the physical shape be constant? It need not necessarily be. For example, any lens can be in any of these three shapes. Okay, it can be biconvex, plano-convex, or concavo-convex, known as the converging meniscus. Likewise, it can be biconcave or equiconcave, plano-concave, or diverging meniscus. Now, how is this possible? As I told you, the power of the lens is the addition of this as well as this. So suppose we have minus 4 is the power of the lens. So the front power can be 2, the back power can again be 2. So as per nominal formula, the total power becomes 4. Here, since it is plano, the front power is 0 and the back power is plus 4. Again we get the same final result. Here it is a concavo-convex. So let's say the front power is plus 6 for example. The back power is minus 2, again leading to 4 diopters. So as you can see in the given examples, depending on the shape of the lens, the power distribution in the anterior and the posterior curves differ, but the end result finally is the same. Likewise, the similar example we can also see in the biconcave lenses also. It can be like, say, minus 4 diopters is the final power. It can be minus 2 and minus 2 giving minus 4, or 0 adding minus 4 giving us the final power as minus 4 diopters, and here maybe we can have minus 6 and plus 2 again giving us minus 4 diopters. So as you can see from all these examples, a lens need not have the same shape, but still the final optical power can be same. So this is where our simple transposition comes. So simple transposition essentially means converting one power into another with the same end result. When I say same end result, it must be optically same. That is what a simple transposition achieves. Okay, so let's see what are the clinical applications for a simple transposition. So transposition can be done as a way of communicating between professionals. For example, an ophthalmologist might like to write his prescription in a plus cylinder. An optician may like to work with a minus cylinder. So when you transpose, the final result of the dispensing prescription is the same. So the patient doesn't lose anything because of the transposition that has been done. Likewise, in keratometry and topography, values are invariably expressed as plus cylinders. But when you want to convert it into a subjective refraction, it is better to transpose it into minus cylinder so that we will be able to provide the prescription in minus cylinders. Minus cylinder forms are thinner and have a comparatively less aberrations, and most of the spherocylindrical prescriptions are prescribed in minus cylinders for this. And finally, lensometer readings. You have one patient comes carrying one prescription, your lensometer is giving another prescription. When you transpose, you might find that both of us are dealing with the same prescription. So we have to know, to deal with all these things, we have to know what is simple transposition. So as I already told, it is conversion of a spherocylindrical prescription into a different power, cylinder. Okay, for example, maybe a plus cylinder into a minus cylinder without changing the final optical value. Okay, so our final optical value must be the same. Okay, so this is the use of simple transposition. So we saw what is simple transposition and what are the uses of simple transposition. Now, how do we go about doing it? So it is essentially made up of 3 steps. So what are these 3 steps of simple transposition? The first step involves adding the sphere and the cylinder algebraically. This is very important, because see, suppose you have a 3 sphere and a +1 cylinder. When you add algebraically, it becomes +4. Whereas the same 3 sphere, if you have a minus cylinder, your final result will be +2. Okay, so this is one area where we commonly make a mistake. So please see to that the sphere and the cylinder are added algebraically, that is, give respect to the signs, plus and minus signs. What is the next step? Next step is not a big issue. All you have to do is change the sign of the cylinder. Suppose the prescription is -1, all you have to do is make it into +1. The prescription is +1, just change it into -1. So just change the sign of the cylinder. Okay. Now what is the third step? The third step is rotate the axis by 90 degrees. What is rotate the axis by 90 degrees? See, whenever you have a value which is less than 90, all you have to do is add 90 to that value. So if this x is less than 90, you add 90 to that. The new value is the axis of the new cylinder. Suppose the x is greater than 90, then you subtract 90 from this to get the new meridian of this transposition. So these are the ways how you rotate the axis. Like I already told, if the initial degrees is less than 90, you add 90, and if it is greater than 90, you subtract 90 from that. Okay, so here is the example. If the old axis is 30, we know that it is less than 90, so we are going to add 90. We get 120, which is a valid prescription. If it is 90, yes, we again add 90, because up to 90 we have to do the same thing. Again we get 180, it's okay. Suppose it is greater than 90. Here we have 120, which is greater than 90. So as I already told you, if it is greater than 90, we have to subtract 90 degrees from that. So we have subtracted it. We ended up getting 30 degrees. So which is the correct value. Likewise, if you have 180, you again subtract 90, getting 90. If our value is 0 degrees, just add 90. Okay, so this is how we are supposed to rotate the axis by 90 degrees, and the end result must always fall between 1 degree and 180 degrees. We have learned about what is simple transposition. Yes, how to do it, and uses of simple transposition. Now let's work on some examples and see how much we have learnt it. So here we have an example. What is the original? This is the original prescription. -3, -1.5 at 90. So what is the first step? First step asks us to add the sphere and cylinder algebraically. So you add -3 and add -1.5, giving a new value as -4.5. So this is the new sphere, -4.5. Then the second step is change sign of the cylinder. What was the original cylinder? -1.5. So we are changing it into +1.5. So this becomes the new cylinder. Then finally rotate it by 90 degrees. We have already seen, if the old axis is 90, you add 90 to that, you get 180. So this is the new axis. So our new prescription is -4.5 sphere plus 1.5 cylinder at 180 degrees. So this is the transposed value. Okay. So let's see another example. Here the sphere is plus, the prescription is +2 plus 1.5 at 180. So again, first step is add sphere and cylinder algebraically. +2 plus 1.5 giving +3.5, which is the value of new sphere. Change the sign of the cylinder. So instead of +1.5, our new cylinder is -1.5 cylinder. Rotate the axis by 90 degrees. It is 180. Since it is more than 90, we deduct 90 from the thing, getting the new axis as 90 degrees. So what will be the new prescription? It is +3.5 minus 1.5 at 90 degrees. So this is the transposed value of the given prescription. One more example. -1.5 sphere minus 2 cylinder 45 degrees. So again, let's go through the regular thing. We are going to add the sphere and cylinder, which is -1.5 and -2 gives -3.5, which is the value of the new sphere. The axis, the cylinder sign has been changed. So now the new cylinder is +2, correct? So that is the new cylinder. Rotating it by 90 degrees. Since it is less than 90, we are going to add 90 to this 45, which gives the new meridian. So what is the new transposed prescription? It is -3.5 sphere +2 cylinder at 135 degrees. So this is the transposed value. Now one final example where there is mixed signs. Here we have plus sphere minus cylinder at 150. So again the same thing, we have +1. We are supposed to add algebraically. So when you add +1 to -3, we get -2, which is the new sphere. We have changed the value of the cylinder from minus to plus. So this becomes the value of the new cylinder. Rotating it by 90 degrees. Since it is more than 90, we are going to deduct 90 from 150, which gives us the value of 60 degrees. So our final prescription will be -2 sphere plus 3 cylinder at 60 degrees. So this is the transposed new prescription. So we have seen what, when, how and why to do simple transposition, correct? Before proceeding, we have to know what are the common errors that we can make and how to avoid them. So what are the common errors in transposition? The first thing is forgetting to add sphere and cylinder algebraically. I already told you the sign is very important, okay? And when we are adding two minus signs, we'll end up with a higher value, or adding two, that is two values of the same sign, we'll always end up with a higher value. When we are adding two values of opposite signs, we end up with a smaller value. So make sure that you have done the first step correctly, that is adding has been done arithmetically. Second step, in our confusion we will always forget to change the sign of the cylinder, okay? So always remember, if you go in an organic manner, orderly manner, we will never make a mistake. So our second step is change the sign of the cylinder. So once you do that, we will not make any mistake. Rotation of the axis. See, as I told you, our end result must always be within 1 degree to 180 degree. So if you end up with some value like this, that simply means we have made a mistake in calculation, okay? So always remember, less than 90 means add 90 degrees, greater than 90 means deduct 90 degrees from the value. So our axis value will always stay within this range, okay? So this valid range, always remember, anything if you get beyond this, that means we have made a mistake and our transposition is wrong. Now, how do we verify that we have done it correctly? Okay, we know that there are 3 steps. We think that we have done the steps correctly, but how to verify that our end result is correct? Okay, so let's go back to one example that we solved. Okay, so this was the example where the initial prescription was -3, -1.5 and 90. We transposed it and we got this value. So to verify it, all you have to do is transpose this. So if you transpose this, we must end up with this. Okay, so let's see if our theory is correct, whether we have done correctly. So let's transpose again. What is the first step? Algebraic addition of the sphere and cylinder. So minus 4.5 plus 1.5. What does that give? So minus 3. That is the value of the sphere. Changing the sign of the cylinder. So it is plus 1.5. So minus 1.5 is the new cylinder. Axis, old axis is 90. Since it is greater than 90, we are going to subtract 90 from that, which gives 90 degrees as the new axis. So what have we ended up with? Our new sphere is minus 3 sphere, minus 1.5 cylinder at 90 degrees. So we have come back to our original prescription. That simply means we have done it correctly. Okay, another way of verifying our transposition is to find out the spherical equivalent. So what is spherical equivalent? Spherical equivalent is nothing but sphere plus half of cylinder. Again, it is an algebraic addition. So what is the sphere here? It is minus 4.5. What is the cylinder? It is 1.5. Half of 1.5 is plus 0.75. Okay, so if you add plus 0.75, what do we get? We get minus 3.75, right? Okay, so this is spherical equivalent of this prescription. Let's see whether when we do the spherical equivalent of this, do we get the same value? Here we have minus 3, yes. Half of the cylinder, half of minus 1.5 is minus 0.75. Again we add that, we end up with minus 3.75 again. So the spherical equivalent of this prescription and the spherical equivalent of this prescription is the same. Hence our transposition is correct. So let's assess whether we have followed all the instructions and we have understood the procedure of simple transposition. So the first question is transpose the following into a plus cylinder form. Okay, so what have we learned? Minus 2.5 is the sphere, minus 1.25 is the cylinder. So we are going to add them algebraically, which gives minus 2.5 minus 1.25, which will give minus 3.75 as the new sphere. Okay, we are going to change the sign of the cylinder, which makes it plus 1.25 cylinder, and since it is less than 90, we are going to add 90 to the 75 degrees, which will give 165 as the new value. So the final prescription is 3.75 sphere, 1.25 cylinder plus, and the degree is 165. So this is the answer. So when transposing, if the original axis is 130, the new axis will be, we know if it is greater than 90, we have to subtract 90 from that. So that gives 40 as the new axis. So B is the correct answer. So to summarize, there are three steps. To find out the new sphere, we have to do the algebraic sum of the sphere and cylinder. The new cylinder is just the same cylinder with the sign changed. If it is plus, you change into minus. If it is minus, you change into plus. And the new axis, depending on whether it is less than 90 or greater than 90, you either add 90 degrees or subtract 90 degrees. And if at all you still have a doubt as to whether we have done it correctly, transpose your answer back, and if you get your original question, that means you have done your transposition correctly. So take home summary, after doing, first do all the steps orderly, you can never go wrong. In spite of that, if you want to do some self-checking, transpose the transposed prescription, you must recover the original prescription. Second step of again cross-checking is spherical equivalent of both the question and the answer must be the same. Happy transposition. I hope you have understood what is simple transposition. It is very simple as the name suggests. Just we have to be careful and avoid making simple mistakes.